So the big picture for this lesson is sequences. And before talking about sequences, I want to talk about a linear function again. So here's a basic linear function, f of x equals 2x plus 1. The slope is 2. The y-intercept is positive 1. And the domain is x is an element of the set of real numbers. In other words, every real number is an input for the function. It is continuous. It extends in both directions forever, left and right. And there aren't any breaks along the way. So that's a linear function. Now let's look at a sequence. If you look at the points here, they represent the exact same pattern. Y-intercept is 1, or the initial amount, and then the rate of change is 2 each time. But let's look at what the difference is. F of n equals 2n plus 1. Typically, n is used for the input for sequences instead of x. And that's just to help signify it is a sequence. The domain. N, the input, is an element of z. Now, z is integers. The input for a sequence has to be integers only. And also, it's such that n is greater than or equal to 0. So non-negative n values. It starts at 0 for input, then 1, then 2, then 3, then 4. So the pattern is the same, but the result is very different. This is called discrete, which means it's not continuous. There are breaks along the way. It's just a set of points. However, sequences can be used to model a lot of different things, just like functions can. So in this lesson, you're going to be practicing writing the terms in a sequence and creating a rule for a sequence. And there are good explanations for both of those things. That's the big picture for this lesson.